Hello, welcome to the Extraordinaire, where we are committed to the relentless pursuit of excellence. If you love tech and would like to skill up, subscribe to the channel and don't forget to hit the bell icon so you don't miss any of our content. Today, we are going to be looking at packages. Now, packages are a way of structuring Python's modules namespace by using dotted module names. For example, the module a.b designates a submodule named b in a package named a. Just like the use of modules saves the authors of different modules from having to worry about each other's global variable names, the use of dotted module names saves the authors of multi-module packages like NumPy or Pillow from having to worry about each other's module names. Suppose you want to design a collection of modules, a package, for the uniform handling of sound files and sound data. There are many different file formats, usually recognized by their extension, for example, .wav, .aiff.au. So you may need to create and maintain a growing collection of modules for the conversion between various file formats. There are also many different operations you may want to perform on sound data, such as mixing, adding echo, applying an equalizer function, creating an artificial stereo effect. So in addition, you will be writing a never-ending stream of modules to perform these operations. Here is a possible structure for your package expressed in terms of hierarchical file system. This is the top level package. We have the initializing file, the init.py, which initializes the sound package. This is a sub package for file format conversions. Then we have another sub package for sound effects and another sub package for filters. When importing the package, Python searches through the directories on sys.path looking for the package subdirectory. The init.py files are required to make Python treat the directories containing the file as packages, unless using a namespace package, which is a relatively advanced feature. This prevents directories with a common name such as string from unintentionally hiding valid modules that occur later in the module search path. In the simplest case, the init.py can just be an empty file, but it can also execute initialization code for the package or set the all variable, which we'll look at later. Users of the package can import individual modules from a package. For example, if we use the syntax, we are importing the echo function from the effects package, importing the echo module from the effects sub package from the sound package. This loads the sub module sound.effects.echo. It must be referenced with its full name. So we have the module echo, and we are trying to access echo filter, which is a function defined in this echo module, defined in this effects sub package, defined in the sound package. So this is how we would reference the whatever name we are trying to reference in a package. An alternative way of importing a submodule is this. This also loads the submodule echo and makes it available without the package prefix, so it can be used as follows. So this is another way of using it. If we import the submodule like this, we can call it like this. Yet another variation is to import the desired function or variable directly. So we can import it like this. Again, this loads the submodule echo, but this makes it a function. This makes its function echo filter directly available. So we can call it like this. Note that when using from package import item, the item can either be a submodule or sub package of the package. or some other name defined in the package, like a function, class, or variable. The import statement first tests whether the item is defined in the package. If not, it assumes it is a module and attempts to load it. If it fails to find it, an import error exception is raised. Contrarily, when using syntax like import item.subitem.sub-subitem, each item except for the last must be a package. The last item can be a module or a package, but can't be a class or function or variable defined in the previous item. So we have to take note of this. Now, what happens when the user writes from sound.effects import asterisk? Ideally, one would hope that this somehow goes out to the file system, finds which submodules are present in the package, and imports them all. This could take a long time, and importing submodules might have unwanted side effects that should only happen when the submodule is explicitly imported. The only solution is for the package author to provide an explicit index of the package. The import statement uses the following convention. If a package's init.py code defines a list named all, it is taken to be the list of module names that should be imported when from package import asterisk is encountered. It is up to the package author to keep this list up to date when a new version of the package is released. Package authors may also decide not to support it if they don't see a use for importing asterisks from their package. For example, the file sounds/effect/init.py could contain the following code. This would mean that from sound.effect import asterisk would import the three named submodules of sound.effects package. Be aware that submodules might become shadowed by locally defined names. For example, if you added a reverse function to the sound/effect/init.py file, the formed sound.effect import asterisk would only import two submodules, echo and surround, but not the reverse submodule because it is shadowed by the locally defined reversed function. So what we mean by this is, let's say we define this all list in our init.py file. So echo refers to the echo.py file, surround refers to the surround.py file, reverse refers to the reverse function. Now, why? Because we are defining reverse function inside the file as well. This name shadows the reverse.py submodule. In this case, in the case of a from sound.effects import asterisk. So when we import with this syntax, the reverse would return this function instead of the module. If all is not defined, the statement from sound.effects import asterisk does not import all submodules from the package sound.effects into the current namespace. It only ensures that the package sound.effects has been imported, possibly returning an initialization code in init.py, and then import whatever names are defined in the package. This includes any names defined and submodules explicitly loaded by init.py. It also includes any submodules of the package that were explicitly loaded by previous import statements. So let's consider this code. So we've imported sound.effects.echo, we've imported sound.effects.surround, and then we say from sound.effects import asterisk. In the above example, echo and surround modules are imported into the current namespace because they are defined in sound.effects package when the from import statement is executed. This also works when all is defined. Although certain modules are designed to export only names that follow certain patterns, when you use import asterisk, it is still considered bad practice in production. Basically, we want to avoid using asterisk as much as possible. Remember, there is nothing wrong with using from package import specific submodule. In fact, this is the recommended notation unless the importing module needs to use submodules with the same name from different packages. When packages are structured into subpackages, as with the sound package in the example, you can use absolute imports to refer to submodules of sibling packages. For example, if the module sound.filters.vocoder needs to use the echo module in sound.effects package, it can use from sound.effects import echo. You can also write relative imports with the from module import name form of the import statement. These imports using dots to indicate the current and parent packages involved in the relative import. From the surround module, for example, you may use from dot import echo, from dot dot import formats, from dot dot filters import equalizers. Note that relative imports are based on the name of the current module's package. Since the main module does not have a package, modules intended for use as the main module of a Python application must always use absolute imports. Packages support one more special attribute, which is this underscore underscore path underscore underscore. This is initialized to be a sequence of strings containing the name of the directory holding the packages init.py before the code in the file is executed. This variable can be modified. Doing so affects future searches for modules and subpackages contained in the package. While this feature is not often needed, it can be used to extend the set of modules found in a package. So that's it for packages in Python. If you enjoyed the content, do like and subscribe, share with your friends, and I'll see you in the next one. Bye.